Welcome to the Deep Dive, your shortcut to understanding the tech that's genuinely changing things. If you spent any time in tech forums lately, you've probably seen some, well, pretty loud arguments about GPT OSS.
Oh, yeah, definitely.
On one side, you hear people calling it a ChatGPT killer you can run on a laptop.
All right.
And then on the other, it gets dismissed as, like, a spreadsheet with delusions of grandeur.
Right.
No?
Yeah, I've seen that one too. It's quite the split.
So today, we're going to cut through all that noise.
Our mission for this deep dive is really to understand why GPT OSS actually matters. We'll look at, which version might be the right fit for your specific needs, and crucially, how you can unlock its full potential. This isn't about chasing hype.
No.
It's about getting to grips with a laser-focused reasoning engine, one built for developers who really, really prioritize data ownership.
Exactly. Think of this as your practical guide. It's your shortcut to being genuinely well-informed about this pretty powerful tool. We'll share some surprising facts, clear up some common misconceptions, and give you concrete steps so you can not only understand it deeply, but maybe even get hands-on.
Let's do it.
Okay, let's unpack this. So, to start, what is GPT OSS? Fundamentally, we hear this term open weight thrown around a lot in AI.
Yeah.
What does that actually mean for us, day to day?
Okay, so in plain English, open weight just means the full neural network weights, the sort of brain of the model, are available for you to download.
Okay.
And this is kind of a big deal because it means no API keys, no NDAs, no needing to rely on some big corporate cloud.
Right.
You literally just take the files, you drop them onto your own GPU, hit run, and the model processes your stuff locally, right there on your machine.
That's a huge shift from the usual cloud models, a really big difference. And I understand it comes in different sizes, different flavors for different setups.
That's right. Yeah, two main flavors. The first is GPT OSS 120B. That's the powerhouse. It's got 117 billion total parameters, which sounds massive, but here's the clever bit.
Yeah.
Only about 5.1 billion are active when it's actually running at inference time.
Wow, that's efficient.
Super efficient. It runs pretty nicely on a single 80 gig H100 GPU.
Slight pause. An 80 gig H100.
Yeah, I think like a lot of our listeners, I don't quite have one of those just lying around.
Hey, fair enough. Not standard home equipment for sure.
So for the rest of us mere mortals, what's the accessible entry point?
Okay. That's where DPTOS 20B comes in. We call it the workhorse.
The workhorse, I like that.
It's got 21 billion parameters total, but only a lean 3.6 billion active, which makes it slim enough for, say, a 16 gig consumer GPU, or even a modern MacBook Pro can handle it.
Really? On a MacBook?
Yeah, a recent M-series one, definitely. So if you're looking to just explore this tech at home, the 20B version is absolutely the place to start.
Got it. So it's clear this isn't just another ChatGPT clone. How exactly is it different from those, chatty generalists we get from OpenAI and others? What's its real specialty?
Absolutely. Yeah, think of those OpenAI models as like general conversationalists that are great for a wide range of stuff. GPT OSS is fundamentally different. It was specifically tuned, really focused on STEM reasoning, code triage, things like that, and crucially private deployments where compliance is absolutely paramount. Picture it less like a chatbot and more like a quiet, hyper-focused analyst. Its job is solving complex equations, maybe labeling GitHub issues
automatically. It's not making small talk. And the critical part, it never connects to the cloud. Your data stays put.
That distinction is so important.
Researchers who want to fine-tune models on their own proprietary scientific data without sending it anywhere. And even hobbyists, someone who wants an on-device coding buddy without paying a monthly subscription.
Okay.
The core value here isn't just convenience. It's often a fundamental requirement for security, for compliance, that those big cloud models just can't meet.
That makes perfect sense.
Yeah.
Now let's manage expectations a bit. Who is this not for? Because, the right tool for the right job.
Exactly. The right tool only feels magical on the right nail, as they say.
Okay.
So first off, if you're looking for a full ChatGPT clone for like trivia or writing poetry, This isn't it.
Okay.
Its knowledge base is deliberately narrow. You'll probably spend more time correcting it if you ask about, I don't know, sports scores or something than getting useful output. It can hallucinate outside its domain.
Good to know. What else?
Also, writers looking for that fearless muse for creative writing. It's probably not the best fit.
What is that?
It has a pretty strict safety layer built in by design. It's made to avoid getting into anything spicy, violent, or, morally gray areas.
Oh, okay.
So if you need uncensored creative freedom, you'd probably look at a different kind of open model, one with looser filters.
Gotcha. And what about teams focused purely on hitting the absolute highest benchmark scores, regardless of data privacy or cost?
Yeah, for those teams who just prioritize the raw, top-tier benchmark numbers above everything else, deployment freedom, cost, privacy, then yeah, proprietary giants like, say, O4 Mini might still edge it out by a tiny margin on some specific tests like MMLU or human evil.
Okay.
If you're totally comfortable sending all your data to a third-party cloud and those bragging rights are your main goal, then sure, closed APIs are still an option.
And hardware limitations.
Definitely. It's not for, tiny edge devices with less than 16 gigs of RAM. Even that smaller 20B model needs decent memory headroom. Older machines will definitely struggle.
And one last thing. Managers expecting some kind of one prompt does everything magic bullet. They'll likely be disappointed.
Needs guidance.
Absolutely. GPT OSS really shines when you give it explicit instructions, set the right reasoning level, we'll get to that, and define tools properly. It definitely requires some prompt engineering effort.
Okay, so it's clear GPT OSS isn't a silver bullet. Understanding its strengths and its limits is key. But for those who now see its unique value, the big question is,
How do you actually get your hands on this thing and, make it work well?
Right. So when people ask me how to install GPT OSS, I pretty much give one answer these days: Ollama.
Ollama. Okay.
Honestly, just 2 steps, really.
Step 1, grab Ollama. You can go to their official website, ollama.ai, hit the download button, or if you're on Linux or macOS, just open your terminal and run this one command: curl-fsslhttps.ollama.aa install.sh.
Wow. Okay. A one-liner? That's about as easy as it gets.
Pretty much.
And then, step 2.
Step 2 is just pulling the model itself.
Right.
Once Ollama's installed, you literally just type Ollama run gpt-oos.20b.
That's it?
That's it. That command fetches the smaller 20 billion parameter checkpoint, perfect for first tests, perfect for most consumer hardware.
And if you do have that H100 lying around.
Yeah. If you're ready for the big leagues and have the hardware, you just swap 20B for 120B in that command. Ollama run gpt-os.120b.
That is remarkably simple for something this powerful. Now, you mentioned something earlier, a secret key, an aha moment that completely changes how this model performs.
Yes.
What is it? I'm definitely curious now.
Okay, this is critical, and it's something a lot of the early reviews just completely missed.
Yeah, and it genuinely transforms GPT OSS from what I sometimes call a sleepy intern into a really focused analyst.
okay, I'm listening.
The secret is adding one single line right at the very top of your prompt.
Reason.
Hi.
Reasoning. Hi. Just that. One line. That feels almost too simple.
I know, right?
How big of an impact can that actually have, and why isn't that just the default setting?
It is honestly night and day. The difference is dramatic. I tested
It with that classic river crossing puzzle, you know the one: wolf, goat, cabbage.
Yeah, get them across the river without... Yeah.
Right. So with the default settings, GPT OSS completely failed. Its strength.
quick, low effort response where deep reasoning isn't needed.
Right.
But for anything that requires structured thought, complex problem solving, that tag is absolutely indispensable.
That's genuinely incredible.
Yeah.
A single line makes that much difference. That's exactly the kind of practical, surprising insight our listeners come here for. It immediately boosts the tool's effectiveness for anyone trying to use it for real work. All right, so we know how to get it running, and we have that crucial tip for making it smarter. Now let's talk about going beyond simple prompts. How do we build something genuinely agentic? You mentioned local models often struggle with rigid instructions or separating thinking from the final answer. But GPT OSS has a specific way around this, right?
It does, yeah. It leverages something called the Harmony prompt format. You might see these angle bracket tags in examples like start or channel or end.
Yeah, I've seen those.
They look a bit like extra markup at first glance, maybe a bit fiddly, but they're actually a really clever, rigid stage direction system for the model.
Stage direction, okay.
And it solves basically 3 fundamental problems you hit when trying to build robust agents locally.
Okay, let's break those down. What's the first problem Harmony solves?
Okay, first, these tags give you explicit stage direction. Every single turn in the conversation, whether it's from you or the model, starts with start and ends with end.
Right.
This makes the conversation boundaries absolutely crystal clear. Now remember, GPT OSS is a mixture of experts model, which means if it kind of loses track of where it is in the conversation, it can start wasting processing power, wasting tokens, just trying to figure things out instead of actually reasoning.
Okay.
So these start and end tags act like fence posts. They keep it from derailing, keep it focused on the current step.
Got it. Keeps the model from getting lost. What's the second function then?
The second thing Harmony does is split the model's output into 2 explicit channels. Analysis and final.
Analysis and final, okay.
Yeah. Think of the analysis channel as the model's private scratch pad. That's where its chain of thought reasoning goes, step-by-step working, maybe its logic for choosing a tool, all the messy internal stuff.
Right, the thinking process.
Exactly. And then the final channel is just the polished, concise answer that's actually meant for human eyes, for the user interface.
Ah, that's clever. So you get the transparency of seeing how it thought, but without cluttering the actual answer.
Precisely. You get both transparency and a clean output.
Okay, smart. And the third crucial function you mentioned?
The third thing is that Harmony tags act like built-in traffic lights for calling tools or functions.
Tools, like external code.
Exactly. When the model decides it needs to use a function you've made available to it, it finishes its analysis block with a specific tag call.
Okay.
And right after that tag, it spits out a perfectly structured JSON payload containing the function name and the arguments it needs.
Ah, so your code just listens for that tag and the JSON.
Exactly. Your external code can easily parse that, execute the function, get the result back, and then feed that result back into the conversation for the model's next turn.
That seems much cleaner than trying to, parse function calls out of plain text.
Oh, way cleaner. Without this strict system, you'd be stuck writing fragile, regular expressions, trying to guess if the model meant to call a function and extract the parameters. Harmony just bakes that separation right into the grammar. It's much more robust.
Okay, so for listeners wanting to structure their own prompts for GPT OSS, what does a typical Harmony prompt actually look like? What are the key parts?
You'll generally have 3 main blocks. First, a system block. That's for global settings, like putting our reasoning high tag in there.
Right.
Then you have a developer block. This is where you define your custom rules and, importantly, describe any tools or functions you want the model to be able to use.
So you tell it about your Python functions there.
Exactly. Name, description, parameters it expects. And finally, there's the user block. That's where you state the actual problem or ask the question you want the model to solve.
System, developer, user. Got it.
And it's really worth embracing this structure early on because, honestly, GPT OSS kind of refuses to work reliably without it. It's pretty fundamental to how it operates best.
Good to know. So, to make this really concrete, you had a great example. Building an offline scam filter. How would we actually do that using GPT OSS in this Harmony format?
Okay, yeah, let's walk through. Imagine the goal. A simple, real-world email spam filter. It needs the model to understand the text of an email and then make a decision locally, right? Conceptually, it's maybe 3 key steps. First, on your machine, you'd write a simple Python function. Let's call it method spam.
Okay.
And maybe this function just looks for certain
Keywords in the email subject or body things like lottery, Bitcoin, urgent, Prince, you know the type.
Yeah, the classics. Okay, so you have the Python function.
Right. Step 2.
Telling the model what tool it has and how to use it.
Exactly. Then, step 3. In the user block of your prompt, you just present the actual email content you want classified.
Okay.
Now, GPT OSS reads the email in the user block. It sees those trigger words, lottery, prints. It consults the tools you define in the developer block. It intelligently decides, this looks like spam. I should call the mark as spam function. Then in its analysis section, it might outline its reasoning. And crucially, it ends that section with the call tag, followed by the JSON function, mark as spam arguments subject.
And your Python script picks that up and flags the email.
Precisely. The Harmony format keeps the model's reasoning process private in the analysis channel, and the tool call itself is perfectly clean, machine-readable JSON for your code to handle. No messy parsing.
That's incredibly powerful. It's not just generating text. It's actively deciding to use a local tool based on the input. Could you expand this? What else could you build like this?
Oh, absolutely. This pattern is really flexible. You could easily add another function, maybe summarize mail, right?
Or categorize invoice if you're processing attachments. You describe those tools in the developer block too. Then the model can intelligently choose which tool is appropriate based on the user's request or the content it sees.
So it becomes a little agent.
Exactly. You can build a simple yet remarkably powerful local email processing agent this way. Or maybe a tool for automating parts of your workflow, all running entirely on your own machine, keeping your data private.
This really shows how you can move beyond just simple
Q&A prompts and start building sophisticated, intelligent systems that are completely under your control.
That's the goal. That's where things get really interesting.
Okay, so we've covered what it
OSS against the other big open source models out there, the state of the art. We typically look at a few key benchmarks here. There's GPQA Diamond that tests really hard, PhD level science knowledge, MMLU, which is a massive, comprehensive 57 subject college level exam, Human Evil, which tests code generation ability, and AM, which is for competition level mathematics.
Got it. So how does GPT OSS fare in that open source arena? Is it holding its own?
It's definitely competitive. In fact, on math, it's arguably the champion.
Really?
Yeah, it absolutely nails the AM benchmark. The 120B model gets scores like 97.9%, which is phenomenal. It really shows off its strong chain of thought reasoning capability.
Or even 32 billion active parameters.
It means it's doing almost as well with significantly less computational grunt per step. That efficiency badge is a huge part of its appeal. It means, practically, your laptop fans might actually stay quiet.
That's a strong showing for an open weight model.
Mm-hmm.
Now let's pit it against the proprietary players, specifically those mini models from OpenAI and others that many people might use day to day.
Okay. So we're comparing GPDOS 120B and the 20B against models like a 4 mini, maybe O3 mini, older O3.
Right.
And what the numbers show is actually pretty striking. It's near mini parity in many areas.
Near parity with O4 mini.
Yeah, the 120B version lands, quote, within a whisker of 4 mini on tough benchmarks like GPQA and MMLU.
Wow.
Which is highly notable for an open license model that you can actually download and run yourself locally.
That is notable. So it's really punching above its weight class, especially thinking about that smaller 20B version too. How does that little workhorse fare against the minis?
It's a real overachiever, the 20B. It actually outguns O3 mini on coding benchmarks and some specialized tasks like health queries. Seriously, the 20B beats O3 mini on coding.
On some key coding tests, yes. And it does this while taking up, a fraction of the memory footprint.
Incredible.
So across the board, both GPT OSS checkpoints consistently post what you might call silver medal scores when compared to these proprietary peers. But, and this is key, they achieve those scores while consuming fewer active parameters per token than pretty much any of the proprietary competition.
So it really is the king of efficiency in that comparison.
It really seems to be.
That paints a really clear, honest picture. So if I'm looking at all this, the capabilities, the limitations, the benchmarks, what's the real story here? Is it a generalist killer or is it more of a specialist marvel?
I definitely say it's a specialist marvel. The honest story is that GPT OSS isn't trying to be a general knowledge encyclopedia.
Right.
It might forget soccer scores or capital cities more often than, say, ChatGPT. It's not designed to write your next novel. That's not its strength.
But when you give it a structured puzzle, a complex reasoning task, a chunk of source code to analyze or debug, that's when its unique mixture of experts engine really lights up and excels. And then you add in the killer feature, the fact that you can host it entirely yourself behind your own firewall, guaranteeing complete data privacy. Well, that creates a unique and incredibly compelling value proposition that most proprietary models simply cannot offer.
So to kind of wrap up this deep dive then, GPT OSS isn't designed to replace your everyday chat companion.
No, it was never meant for that.
Instead, it offers something that feels increasingly
problem solving, often outperforming much larger open models in terms of pure efficiency.
It's more done with less.
And by using that Harmony prompt format, it keeps the thinking process transparent but separate, while giving you those clear, structured answers and enabling robust tool use.
Yeah, the Harmony format is key to unlocking its agentic potential.
And maybe most importantly, it provides a really viable, secure path for teams and companies to fine-tune and deploy powerful AI without ever having to send their sensitive data to a third party.
That's the bottom line for many users, absolutely.
This doesn't feel like just marketing hype. For engineers who really value privacy, for researchers who crave transparency, for companies that simply cannot send their sensitive IP over the wire. So maybe our challenge to you is install it. It's easy with Ollama. Explore using tools with GPT OSS via the Harmony format. Run your own benchmarks on the problems you care about and judge for yourself.